Good morning, students. In this session, we are going to see a top subject hybrid and electric vehicle technology from the Unit 1 introduction area, and the topic is history of hybrid and electric vehicle. What is hybrid electric vehicle? A vehicle that has a two or more energy conversion technologies combined with one or more energy storage units is called as a hybrid electric vehicle. Hybrid electric vehicle objectives. It wants to obtain the maximize fuel economy, fuel and minimize the fuel emissions and minimize the propulsion system cost to keep affordable and maintain an acceptable performance with a reasonable cost. Reduce the conventional car weight. The advantages for conventional engines. It is a regenerative braking and the reduction in engine and vehicle weight and the fuel efficiency is increased, emission are decreased and cut emissions of the global warming pollutants by 1/3 or off conditions and reduce the independence of fossil fuels and some states offer incentive with owing of HEV and 2 times more efficient than the conventional engines. Motor components. It consists of accessories, management, energy management and the system controls, body chassis, fuel tank and the thermal management system and the hybrid unit and the traction motion and the energy storage units. The drivetrains are the electric motors and controllers and the electric energy storage systems and the hybrid power units and the transmissions. The motor components are electric motor and controls. The basic components of electric motor and controls are an armature or rotator, accumulator and the brushes, an axle and the field magnet and the DC power supplies. This is a diagram for electric motor controllers. It consists of all the components we have mentioned before. The advantage electronics allows the motor to act as a generator and draw energy to accelerate and regenerate the battery when the slowing down. The motor uses the magnet and magnetism to create motions. Electric energy storage system. The batteries are lithium ion and the nickel metal hybrid batteries, ultra capacitors and the flywheels. The desirable attributes are high peak and pulse specific power, high specific energy at pulse power and the high charge to maximize the regenerative braking and it gives a long life. Whereas the challenges we are facing is accurate techniques to determine battery state of charge, develop the abuse tolerance batteries and recyclability. These are the batteries and the current uses which combine to the nickel metal hybrid and the lithium ions. We consist of the current uses, life cycle, current contribution, challenges and the miscellaneous. The energy storage ultra capacitors. The storage energy as a electric charge in a polarized liquid layer between an ionical electrolyte and conducting electrode, primarily used for acceleration and climbing hills and the regenerative braking. Energy storage in flywheel. A store kinetic energy with a rapidly spinning wheel and the complex, heavy and large contains no acids or hazardous material. It is not affected by a temperature. It delivers a smooth flow of power. Click more information on the flywheels. It is a principle of operations. The charging and discharging the battery. The following some links to visual display the characteristics of the motor and engine during the different scenarios. First one is a different driving at low speeds and the city driving and the highway driving. Then fourth one is uphill driving and the coasting and slowing and stopping. Regenerative braking. When a driver brakes, the motor becomes a generator and the kinetic energy generates electricity stored in a battery. The data process uses 30% of the heat lost kinetic energy from braking. Hybrid power units. There are four types. First one is a compression ignition direct injection engine, spark ignition engine, gas turbines, and the fuel cells. Hybrid power units. The most promising power unit achieves a combustion through a compression without a use of spark plug. The high pressure engine of the fuel into a combustion chamber, throttle and heat losses travels into a combustion chamber, increasing the thermal efficiency. This is spark ignition system. Uses a homogeneous air fuel mixture before entering the combustion chamber. When the combustion chamber is compressed, the spark plug is ignited, controlled by limiting the amount of air allowed into the engine. It is a gas turbine. Runs on a Brayton cycle. A compressor raises the pressure and temperature of the inlet air. Air is removed to the burner and fuel is injected and combusted to raise the air temperature. The power is produced when the heat pressure mixture is expanded and cooled through the turbine. The fuel cell method. Generated electricity through an electrochemical reaction combining the hydrogen with ambient air. The pure hydrogen or any fossil fuel produced is used as a hydrogen rich gases. The water vapor is emitted. Transmissions of four types. First one is a continuous variable transmission, automated shifted transmission. Third one is a manual transmission, and the last one is a traditional automatic transmission with torque converter. Transmission. First one is a infinite number of variable transmissions. Currently not able to complete the 4-speed and 5-speed transmission in size and cost and reliability. Provides a seamless, stepless acceleration and deceleration. The series of power assist and parallel to the range extender, and dual mode is a combination of series and parallel. It is a propulsion methods. In propulsion methods, we have a generator, power unit, energy storage, and the motor and control and the transmission area. Series configuration. A small fuel burning engine that directly drives an alternator to generate electricity. The electricity is stored in a battery or sent to the electric motor when the batteries are drained to certain level. The engine turns and recharges the battery. Parallel configuration. The two power paths. The hybrid power unit or electric propulsion system or both can power the vehicles for long trip and the engine is used. For hills acceleration and the high power scenarios, the electric motor is used. It is the benefits of series configuration and the parallel configuration. The examples are Toyota Paris and the Honda Insight. These are specifications. Hybrid vehicle challenges. The energy store device with a high power to energy ratios, frequent shutdown and startup of the vehicle, reduce the size, weight and cost, higher efficiency in the conversion of fuel to use power. The advanced configuration for the propulsion system components. Thank you.